Hey gearheads, Jay Leno here. Today we're diving deep into the very essence of what makes your car tick. Ever popped the hood of a car and wondered what's going on in that hunk of metal? It's not just a random assortment of parts, it's a marvel of engineering. That, my friends, is the engine, the heart of your car. It's the powerhouse that breathes life into your vehicle, making it more than just a metal shell. It's a symphony of controlled explosions, turning fuel into motion. Each piston moves with precision, creating a rhythm that propels your car forward. Think of it like this. The engine is a bit like a stomach. Just as your stomach digests food to give you energy, the engine processes fuel to power the car. It takes in fuel and air, mixes them up, and then digests them to create energy. This mixture is ignited, causing tiny explosions that drive the pistons. But instead of burps, it makes horsepower. That raw power is what gets you from 0 to 60 in seconds. Now you might be thinking, Jay, that sounds complicated. But stick with me. We're going to break it down into simple, digestible parts. Once you break it down, it's actually pretty straightforward. Each component has a specific role, working together in harmony. We're going to take a ride through the inner workings of a car engine, from the fuel tank to the wheels. Buckle up. By the end of this journey, you'll have a newfound appreciation for the incredible engineering that goes into every car. So let's get started and explore the heart of the machine together. First things first, let's talk fuel. Fuel is the lifeblood of any vehicle, whether it's gasoline, diesel, or even electricity. But for now, let's focus on gasoline, the most common type of fuel used in cars around the world. We all know cars need gas, or diesel, or electricity, but we'll stick with gas for now. When you pull up to a gas station and fill up your tank, you're essentially giving your car the energy it needs to run. But how does it get from the tank to the engine? Well, it's a journey. A fascinating journey that involves several key components working in harmony to ensure your car runs smoothly. The fuel pump, like a little mechanical heart, draws the gas from the tank and sends it through fuel lines. This pump is crucial because it ensures that the fuel is delivered at the right pressure to the engine. Think of these lines like arteries, carrying the lifeblood of the engine. These fuel lines are designed to withstand high pressure and are made of materials that can resist the corrosive nature of gasoline. The fuel then goes through a filter because even engines like their drinks clean. This filter is essential for removing impurities and contaminants that could potentially harm the engine. This filter catches any dirt or gunk that might be in the gas, keeping the engine running smooth. Over time, the filter can get clogged, which is why it's important to replace it regularly. Finally, the fuel reaches its destination, the cylinders. These cylinders are where the fuel is mixed with air and ignited to create the power that moves your car. These are like individual chambers where the magic happens. Inside each cylinder, a precise amount of fuel is injected and mixed with air. This mixture is then ignited by a spark plug, causing a small explosion that pushes the piston down and turns the crankshaft, ultimately powering the car. This process happens thousands of times per minute, creating the continuous motion needed to keep your car moving. It's a marvel of engineering and a testament to the ingenuity of automotive design. So next time you fill up your tank, take a moment to appreciate the complex journey that fuel takes from the tank to the cylinders. It's a journey that powers your adventures, commutes, and everything in between. Now, fuel needs a dance partner, and that's where air comes in. Without air, the fuel would just sit there, unable to ignite and power the engine. Air is the unsung hero in this combustion process, playing a crucial role in making sure your car runs smoothly. Just like we need oxygen to burn calories and keep our bodies functioning, engines need air to burn fuel and generate power. The air mixes with the fuel, creating a combustible mixture that ignites and drives the pistons. This is the heart of the engine's operation. Air enters through the car's air intake, often located somewhere near the front grille. This strategic placement ensures that the engine gets a steady supply of fresh, cool air, which is essential for optimal performance. The design of the air intake system is crucial for maximizing airflow and efficiency. This allows the engine to breathe in a big gulp of fresh air, much like an athlete taking a deep breath before a sprint. The more efficiently the engine can take in air, the better it can perform, delivering more power and better fuel economy. But it's not just about quantity, it's about quality too. The air needs to be clean and free of contaminants to ensure the engine runs smoothly and efficiently. Dirty air can cause all sorts of problems, from reduced performance to increased wear and tear on engine components. That's why many cars have air filters, which work like the engine's nose hairs, trapping dust and debris before they can get sucked in. These filters are essential for maintaining the health of the engine, preventing harmful particles from causing damage and ensuring that only clean air enters the combustion chamber. Once the air is filtered, it joins the fuel in the cylinders, ready for the big show. This precise mixture of air and fuel is then ignited by the spark plug, creating a controlled explosion that drives the pistons and powers the car. It's a finely tuned process that relies on the perfect balance of air and fuel to keep your engine running smoothly and efficiently. We've got fuel in the cylinders, we've got air in the cylinders. Now what? We need a spark to set it all off. That's where spark plugs come in, those little guys that look like miniature lightning bolts. Each cylinder has its own spark plug, connected to the car's electrical system. When the time is right, the spark plug creates a jolt of electricity, igniting the fuel-air mixture in a mini explosion. This explosion is carefully timed and controlled, and it's what creates the power that makes your car go vroom. Section 5. Pistons pumping, the engine's muscle. Now, those explosions in the cylinders, they create a lot of energy, and that energy needs somewhere to go. Enter the pistons, the engine's heavy lifters. Each piston sits inside a cylinder, and when the fuel-air mixture explodes, it pushes the piston down with tremendous force. It's like a power lifter doing a rep, only much faster and louder. This up and down motion of the pistons is the heart of the engine's operation. It's the raw power that gets everything moving. Section 6. Cranking it up, from up down to round and round. So we've got pistons moving up and down, but cars don't move like that, do they? We need to convert that linear motion into rotational force, and that's where the crankshaft comes in. The crankshaft is a cleverly shaped piece of metal that connects to all the pistons. As the pistons move up and down, they push on the crankshaft, making it rotate. Think of it like a bicycle's pedals and crank arms. Your legs go up and down, but the bike's wheels go round and round. Same principle here. Section 7. Getting a grip transmission takes charge. Now we're getting somewhere. The crankshaft is spinning, but we need to get that power to the wheels. That's where the transmission comes in, acting like the car's gearbox. The transmission takes the rotating power from the crankshaft and sends it to the wheels, allowing you to change gears for different speeds and driving conditions. Think of it like shifting gears on a bicycle, using different size sprockets for different terrains. The transmission does the same thing, but with a lot more gears and a lot more complexity. Section 8. Out to the wheels. Power to the pavement. Finally, the power reaches its destination, the wheels. The transmission sends the rotating force from the crankshaft to the car's wheels through a series of gears and axles. The wheels then grip the road, using the engine's power to propel the car forward, or backward if you put it in reverse. And there you have it. The engine has done its job, converting fuel into motion and getting you where you need to go. Section 9. Keeping it cool, oil's vital role. Now all this internal combustion generates a lot of heat. We're talking about controlled explosions happening thousands of times per minute. That's why engines need oil, their own personal cooling system. Engine oil, pumped throughout the engine, acts as a lubricant and a coolant. It reduces friction between moving parts, preventing wear and tear, and it helps to dissipate heat, keeping the engine from overheating. Think of it like this. Oil is to an engine what sweat is to a marathon runner. It keeps things running smoothly and prevents a meltdown. Section 10. The exhaust note. What goes out? We've talked about what goes into the engine, but what about what comes out? Well, besides power, engines also produce exhaust gases, the byproduct of burning fuel. These gases travel through the exhaust system, which includes the exhaust manifold, catalytic converter, and muffler. The catalytic converter helps to reduce harmful emissions, while the muffler helps to quiet the engine's roar. So, that rumbling sound you hear coming from the back of a car? That's the sound of spent fuel and air making their exit. Section 11. A symphony of power, it all works together. So there you have it, folks. The internal combustion engine, a marvel of engineering where fuel, air, and a spark come together to create motion. From the fuel pump to the spark plugs, from the pistons to the crankshaft, from the transmission to the wheels, every part plays a crucial role in this symphony of power. Next time you turn the key in the ignition, take a moment to appreciate the intricate dance happening under the hood. It's a beautiful thing,